Look up on a clear night, and among the scattered points of light there is one that does not flicker. It burns with a steady, patient glow, and for thousands of years human beings gave it the name of the king of the gods. But the ancients did not know the truth. They could not have imagined that this quiet lamp in the darkness is by every reasonable measure a world that should not be there at all. It is too large. It is too strange. And the more closely we study it, the less it obeys the rules we thought governed the heavens. Consider the raw arithmetic, because the numbers are where the strangeness begins. Jupiter is so vast that every other planet in our solar system could be poured inside it, and there would still be room to spare. Its mass is roughly 2.5 times the combined mass of all the other planets put together. If you have ever felt small standing at the edge of the ocean, understand this. The ocean, the Earth, everything you have ever touched would vanish inside Jupiter like a single grain of sand dropped into a cathedral. And yet, size alone is not what unsettles the astronomers. What troubles them is the question of how something this immense came to be at all. The laws of planetary formation, as we understood them for most of the 20th century, struggled to explain a body of Jupiter's scale forming where it did, in the time it had. There is a theory in physics called core accretion, the slow gathering of matter grain by grain, and Jupiter seems almost too heavy, too quickly assembled, for that patient process to account for it neatly. The giant, in a sense, cheated. There is something else too, something that separates Jupiter from the small rocky worlds like our own. It is made almost entirely of hydrogen and helium, the very same elements that make up a star. In its composition, Jupiter is not a cousin of the Earth. It is a failed sun. Had it gathered perhaps 80 times more mass, the crushing pressure at its center would have ignited nuclear fusion, and our sky would have held 2 burning suns instead of 1. We live, quite literally, beside a star that almost was. So we begin not with an answer, but with an unease. For centuries we called Jupiter simply the largest planet, as if that phrase could contain it. It cannot. Every fact we uncover in the coming minutes will pull us further from the comfortable idea of a planet and closer to something far older and far stranger. Keep one question in your mind as we go, because everything depends on it. If Jupiter is almost a star and almost impossible to explain, then what exactly are we looking at when we look up at that steady light? The answer begins with a world where you could fall forever and never once touch the ground. Imagine for a moment that you could travel to Jupiter and step out onto its surface. Now let go of that image entirely, because there is no surface. There is nowhere to stand. There is no shore, no rock, no crust, no floor waiting somewhere beneath the clouds. What we see when we look at Jupiter is not a planet in the way your instincts understand the word. It is an atmosphere so deep that it becomes the whole world. Begin the descent in your mind. At the top there are clouds, banded in cream and rust and pale gold, colored by chemistry we still do not fully understand. As you sink, the pressure begins to build. The air thickens. What was gas grows dense and heavy, pressing in from every direction with a force that would crush a submarine like paper. There is no clean line where sky ends and ground begins. Instead, the gas slowly, imperceptibly becomes liquid without ever passing through anything you could call a beach or a seabed. This is where the physics turns genuinely alien. Descend far enough and the pressure becomes so extreme, millions of times greater than the air around you right now, that hydrogen itself changes its nature. It stops behaving like a gas or an ordinary liquid and begins to conduct electricity, becoming what scientists call liquid metallic hydrogen. This is a state of matter that does not exist naturally anywhere on Earth, a substance we can barely reproduce for fractions of a second in our most powerful laboratories. On Jupiter, there is an ocean of it thousands of kilometers deep. Sit with the discomfort of that for a moment, because it is worth feeling. We are taught as children that a planet is a ball of rock you could stand on. Jupiter quietly dismantles that lesson. Here is a world larger than 1,000 Earths, and there is no single place on it where a human boot could ever rest. The very idea of a location on Jupiter, a here rather than a there, begins to lose its meaning the deeper you go. And this changes how we must think about everything that follows. The storms we are about to witness are not weather passing over a landscape. They are the world itself, in motion all the way down. When we speak of Jupiter's greatest storm, we are not describing something happening on the planet. We are describing the planet happening, because somewhere in that bottomless sky, one storm has been turning and turning and turning since before your great-grandparents were born. Some believe it began before the telescope was even invented. What could keep a single tempest alive for that long? There is a wound on the face of Jupiter, and it has a color like dried blood. We call it the Great Red Spot, a name so plain it almost hides what it truly is. This is not a mark. It is not a feature. It is a hurricane, and it has been raging without pause for at least 3.5 centuries, possibly far longer. When astronomers first turned their crude telescopes toward Jupiter in the 1600s, it was already there, already ancient, already spinning. Let the scale of it settle over you slowly. This single storm is so enormous that the entire Earth could be dropped into it and swallowed whole, with room around the edges. For generations, it was wide enough to hold 2 or even 3 planets like ours side by side. Every human life that has ever been lived, every war, every love, every quiet, ordinary morning, all of it could fit inside this one storm with space left over. And it has simply gone on turning through all of it, indifferent, patient, immense. On Earth, a hurricane is a brief and violent thing. It gathers its strength over warm ocean water. It rages for days, perhaps a week, and then it meets the land or the cold, and it dies. That is the natural life of a storm. It is born, it destroys, it fades. This is the rhythm we know. But the Great Red Spot obeys no such rhythm. It has no coastline to break it, no cold shore to starve it, only the endless deep atmosphere feeding it, generation after generation. And yet, it is not truly eternal, and that may be the most haunting part of all. In recent decades, careful measurements have shown that the Great Red Spot is shrinking. Once broad enough to cradle 3 Earths, it has grown narrower, rounder, more compact within our own lifetimes. Something that outlasted the rise and fall of empires, that turned steadily through the entire age of modern science, is quietly beginning to change. We may be among the last generations to see it as the giant it has always been. There is a strange intimacy in that thought. This storm was old when Galileo was young. It was turning when your ancestors were born, and it turns still at this very moment as you sit here. It asks nothing of us and knows nothing of us. And still, standing in the presence of something that has endured so long, one cannot help but feel very briefly held inside a much larger sense of time. But do not mistake its endurance for calm. Within that ancient red eye, and across the whole face of the giant, move winds of a violence that no place on earth has ever known. If you could stand inside one, you would not last a single second. We think we know what wind is. We have felt it press against a door we were trying to close. We have watched it bend the trees in a storm and heard it howl at a window pane in the dead of night. The strongest winds ever recorded on Earth, inside our most ferocious hurricanes, reach a little over 300 kilometers per hour, and they are enough to level entire towns. Hold that number in your mind, because Jupiter is about to make it look gentle. On Jupiter, the winds tear through the atmosphere at speeds that reach and exceed 600 kilometers per hour, and in some fierce jet streams they climb higher still. That is roughly twice the fury of the worst storm our planet has ever produced, sustained not for an afternoon, but permanently across bands that wrap entirely around a world 11 times wider than the Earth. These are not gusts. These are rivers of air the size of continents, moving faster than a passenger jet, and they never stop. Try, if you can, to translate the physics into something the body understands. A wind of 600 kilometers per hour does not push against you. It does not lean on the walls of a house. It erases. A city caught in such a wind would not be damaged. It would be unmade, scattered, its every brick and beam torn apart and carried away faster than the eye could follow. There would be no debris settling afterward, no ruins to walk through. There would simply be the wind, moving on, as though nothing human had ever stood in its path. What makes this even harder to grasp is that these winds are not confined to a single storm. They belong to the whole planet at once. Those beautiful stripes you see in every photograph of Jupiter, the cream and amber bands, are not painted decoration. Each one is a colossal current of atmosphere racing in an opposite direction to the band beside it. Colossal rivers of air sliding past one another with a shearing violence that has churned without rest for as long as the planet has existed. And here is the physics that should give us pause. On Earth, our winds are driven overwhelmingly by heat from the Sun. But Jupiter is 5 times farther from the Sun than we are, receiving only a fraction of its warmth. So what powers this ceaseless fury? A great deal of it comes from within, from the planet's own internal heat, a furnace left over from its formation that still burns after 4.5 billion years. Jupiter, in defiance of the distant, feeble Sun, largely storms with a power of its own. A world that heats itself. A world that storms from the inside out. That internal furnace hints at something buried at the very center. Something so strange that some scientists wonder whether Jupiter's heart may be made of a material we usually reserve for wedding rings. Now we step carefully across a line, from what we know into what we suspect. Everything so far has rested on measurement and observation. What follows is different. It is a possibility whispered in the equations, argued over in scientific journals, not yet confirmed by any instrument. But it is a possibility so remarkable that it deserves to be spoken aloud. Deep inside Jupiter, some scientists believe it may be raining diamonds. The reasoning is more sober than it sounds. Jupiter's atmosphere contains methane, a simple molecule built from carbon and hydrogen. High in the atmosphere, violent lightning storms, storms far larger than any on Earth, can break these methane molecules apart, freeing the carbon within them. That loose carbon drifting downward begins a strange journey. As it falls, the pressure around it grows monstrous, and carbon under extreme pressure does something extraordinary. It crystallizes, it hardens, it becomes, in the language of chemistry, the same thing as a diamond. Picture the descent this carbon takes. First it forms soot, then, squeezed harder as it sinks, it compresses into graphite, the soft gray material in an ordinary pencil. Deeper still, where the pressure reaches a level nothing on Earth can match, that graphite is crushed into hardened crystal. And so, in this speculative vision, gemstones are born not in the Earth over millions of years, but in the falling sky of a giant, drifting down through the dark like a slow and glittering rain. We must be honest about what this is and what it is not. No probe has ever descended deep enough to see such a thing, and it may be that the conditions never quite align, that the diamonds are a beautiful phantom of the mathematics rather than a reality. Science demands that we hold this idea lightly, as a hypothesis and not a fact. But even as a hypothesis, it does something valuable. It reminds us how little separates the ordinary from the miraculous. How the same carbon in a pencil and in a wedding ring is only a matter of pressure and time. And it reframes the whole giant in our imagination. This world that has no ground to stand on, that storms from within, that nearly became a star, may also be quietly manufacturing treasure in its crushing depths, treasure no eye will ever see and no hand will ever hold. There is a kind of poetry in a wealth so total and so useless glittering forever in the dark where it can never be spent. A giant that guards diamonds no one can reach. But Jupiter guards something far more valuable than any gemstone, and it has been guarding it for billions of years, whether we deserved it or not. It has been guarding us. There is an old idea, comforting and false, that our planet floats through space in perfect safety. The truth is that the solar system is a shooting gallery. Countless chunks of rock and ice, some the size of mountains, drift and tumble through the dark, and now and then one of them falls toward the inner planets, toward the small blue world where we live. We know what such an impact can do. 66 million years ago, one of them ended the age of the dinosaurs. And yet, across the long history of life on Earth, such catastrophes have been far rarer than they might have been. There is a reason for that, and the reason has a name. Jupiter's enormous mass gives it an enormous gravitational reach, a pull that extends across a vast region of the solar system. Objects that wander too close feel that pull and are diverted, flung onto new paths, hurled out of the solar system entirely, or drawn in and swallowed by the giant itself. In this way, Jupiter has long been described as a kind of cosmic shield, sweeping up or deflecting debris that might otherwise have crossed the Earth's path. It fights a silent, ceaseless war on our behalf, and we were never even meant to notice. We have, on rare occasions, been allowed to witness a single battle in that war. In 1994, a comet named Shoemaker-Levy 9 was torn apart by Jupiter's gravity and then plunged piece by piece into the giant's atmosphere. The impacts released energy vastly greater than all the nuclear weapons on Earth combined, leaving dark scars across Jupiter's face larger than our entire planet. Astronomers watched, stunned, understanding that they were seeing, in one visible instant, the kind of blow that Jupiter has been absorbing quietly for billions of years. It would be too simple, though, to call Jupiter purely our protector, and honest science resists the comfortable story. The same immense gravity that deflects some objects away can also nudge others toward us, sending fresh material tumbling inward from the outer solar system. Researchers still debate the full balance of it, whether the giant has, on the whole, sheltered life on Earth or occasionally endangered it. The war is real, but its accounting is more tangled than any simple tale of a guardian would suggest. Still, when you weigh the long silence of our skies against the violence that surrounds us, it is difficult not to feel a quiet debt. For 4.5 billion years, this distant giant has been part of the reason the Earth had the uninterrupted time it needed for life to slowly, patiently emerge. We owe our long calm, at least in part, to a world we can barely comprehend, spinning far away and asking nothing in return. And that long calm gave life its chance here on Earth. But here is a thought that changes everything. What if Earth is not the only place in Jupiter's neighborhood where life has had that chance? What if it is waiting right now beneath the ice of one of Jupiter's own moons? Jupiter does not travel alone. It moves through space surrounded by a great retinue of moons, dozens upon dozens of them, a miniature solar system of its own. Most are cold and dead, silent rocks locked in orbit. But one of them, a moon named Europa, may be the most important place in the entire solar system beyond the Earth itself. And the reason has to do with what lies hidden beneath its bright, cracked, frozen face. From a distance, Europa looks like a marble of smooth white ice, its surface laced with reddish lines, like the veins in an eye. That ice is its shell, frozen solid in the deep cold of space so far from the sun. But beneath that shell, scientists are now confident, lies an ocean. Not a small pocket of water, but a vast global sea of liquid water, warmed from below, that may hold more water than all the oceans of Earth combined. A hidden ocean, sealed in darkness under a roof of ice, on a moon most people have never heard of. And wherever we have found liquid water on Earth, In every place we have ever looked, we have found life. In the boiling water of deep sea vents, in cracks in solid rock kilometers underground, in the coldest and darkest and most poisonous corners of our world, life has taken hold. Life, it seems, needs three things above all: liquid water, a source of energy, and the right chemical ingredients. And Europa, this small frozen moon of a distant giant, may quietly possess all three. Let yourself feel the weight of what that means, and how patiently we have waited to know it. For as long as we have looked up and wondered whether we are alone, the question has felt impossibly far away, a matter for distant stars and future centuries. But Europa is not in another galaxy. It is here, in our own solar system, circling the giant we have watched all our lives. The answer to the oldest question we have ever asked may be waiting beneath a sheet of ice we could, in principle, reach within a single human lifetime. Nothing is promised. That ocean may be sterile, its dark waters empty, and we must be prepared for silence as an honest possibility. But it may not be. Even now, missions are being prepared to journey to Europa, to study that ice, to search for the faint signatures of something living in the deep. For the first time in the history of our species, the question of whether life exists elsewhere is no longer only philosophy. It is becoming an experiment, and we may live to see its result. So one of Jupiter's moons may cradle a quiet, hidden ocean of hope. But turn to the moon beside it, and you find the exact opposite. A world not of gentle water, but of fire, torn open by a violence that never sleeps. If Europa is a promise whispered under ice, its neighbor Io is a scream of fire. These two moons orbit the same giant, formed from the same distant cloud of matter, and yet they could hardly be more different. Where Europa is smooth, white, and still, Io is the most volcanically violent place in the entire solar system. A tormented world where the ground itself is forever tearing open and spilling fire into the black sky. Io is covered in hundreds of active volcanoes, and they do not erupt gently. They hurl plumes of sulfur and molten rock hundreds of kilometers upward, so high that the eruptions rise clear above the moon into space itself, where the material rains slowly back down across a poisoned yellow and orange landscape. There is no quiet season on Io, no dormant age. The eruptions are happening now, and they were happening 1,000 years ago, and they will be happening long after everyone alive today is gone. It is a world in permanent torment. But why? Io is small, smaller than many might expect for such fury, and small worlds should cool quickly and fall silent, their inner fires long since faded. Io should be a dead, frozen rock. Instead, it burns. The answer lies in a merciless piece of physics called tidal heating. Io is trapped between the crushing gravity of mighty Jupiter on one side and the gravity of the other large moons on the other. And as it orbits, these opposing forces stretch and squeeze the entire moon, kneading it like a fist, closing and opening around a lump of clay. That endless flexing generates friction deep inside Io, and friction generates heat, an immense and unrelenting heat with nowhere to go but out. It is the same principle you feel when you bend a piece of metal back and forth rapidly and it grows warm in your hands. Except here, the metal is an entire world, and the force bending it is the gravity of a giant. Io does not burn because of any fuel of its own. It burns because it is being crushed over and over, forever, by forces it can never escape. Set the two moons beside one another, and you glimpse the strange range of what a single giant commands. Europa, held in the same gravitational grip, may use that hidden warmth to nurture a sheltered ocean where life could stir. Io, held just a little differently, is tortured by that same force into a hell of endless fire. Water and flame, hope and violence, orbiting the same world, shaped by the same invisible hand. Jupiter is not one story. It is many, playing out at once. Water on one moon, fire on another. And still Jupiter hides more from us. There is something encircling the giant that almost no one ever mentions, something that even most who love the night sky have never heard of at all. Ask anyone to name the planet with rings, and they will answer without hesitation. Saturn. Those magnificent bright hoops of ice have been famous for centuries, gleaming in every telescope and every schoolbook. And they are right, of course, but they are also missing something, a secret the giant has kept in plain sight. Jupiter has rings too. Almost no one knows it, and that ignorance is not their fault, because these rings were meant to be nearly invisible. Jupiter's rings are nothing like Saturn's. Saturn's rings are made of bright chunks of ice that catch and reflect the sunlight in brilliant sheets. Jupiter's rings are made of dust, fine dark particles so faint that for centuries we had no idea they existed at all. We only discovered them in 1979, when the Voyager 1 spacecraft flew past the giant and captured, in a single carefully angled image, a delicate band of material we had never known was there. For all of human history before that moment, the rings of Jupiter were a secret the giant kept entirely to itself. And where does the dust of these rings come from? The answer is a small marvel of cosmic economy. Jupiter's inner moons are constantly being struck by tiny meteoroids, and each impact knocks loose a faint spray of dust from their surfaces. That dust, too light to fall back down, drifts into orbit around the giant, forming the delicate rings we now know are there. The rings, in other words, are made from the slowly eroding bodies of Jupiter's own moons, a continuous shedding of material that quietly renews itself across the ages. There is something worth pausing over in how these rings were found, and in what it says about the limits of certainty. For all the centuries that humans watched Jupiter, through every telescope ever pointed at it, no one saw the rings. They were simply too faint, too dark, hidden by the very brightness of the planet they encircle. It took a machine sent across hundreds of millions of kilometers, looking back at the giant from an angle no earthbound eye could ever reach, to reveal what had been there all along. And that is perhaps the quiet lesson of Jupiter's hidden rings. How much of the universe is like this, present and real and utterly overlooked simply because we have not yet found the angle from which to see it? The giant reminds us that even the most studied objects still guard their secrets, that discovery is not finished, that the sky above us is not a closed book, but one we are still barely beginning to read. And in our own time, one machine in particular has turned page after page. Because in recent years, a single spacecraft has been circling Jupiter, closer than anything before it, sending back discoveries that have quietly overturned much of what we believed. Its name is Juno, and what it found changed everything. For most of human history, Jupiter was a light in the sky. Then it was a disk in a telescope. Then, in the age of space travel, it became a world glimpsed briefly by passing probes that flew by and were gone. But in 2016, something different arrived. A NASA spacecraft named Juno, after years of travel across the solar system, slipped into orbit around the giant and stayed, circling closer to Jupiter than any craft had ever dared. And from that unprecedented vantage, it began to send home truths that rewrote the textbooks. The first great surprise lay in the very heart of the giant. Scientists had long assumed Jupiter would have a small, dense, sharply defined core, a compact center buried beneath its vast atmosphere. Instead, Juno's precise measurements of the planet's gravity revealed something stranger. A core that is fuzzy and diluted, blurred and spread out, not a hard sphere at all, but a diffuse region where heavy elements are mixed gradually into the surrounding hydrogen. It suggested that Jupiter's formation was far more violent and complex than anyone had pictured, perhaps involving a colossal collision in its ancient past. Juno looked too at the poles of Jupiter, regions no human eye had ever properly seen, and found a spectacle no one had predicted. Clustered around each pole were vast cyclones, enormous storms arranged in strikingly ordered geometric patterns. One storm at the center, ringed by others in a formation almost too neat to be natural. These polar storm arrangements were unlike anything in our experience of weather, and scientists are still working to understand how such orderly patterns can arise from the chaos of a planet's atmosphere. And the spacecraft peered deeper than sight alone allows, using its instruments to sense beneath the visible clouds. It found that Jupiter's great bands, those famous stripes, are not shallow features painted on the surface, but reach thousands of kilometers down into the planet, and that its magnetic field is far stronger and more irregular than expected, a colossal and lopsided force generated by that deep ocean of metallic hydrogen. Piece by piece, Juno showed us that Jupiter is even less like a simple planet and even more like its own kind of thing than we had ever grasped. What matters most about Juno is not any single discovery, but what the whole mission represents. It is proof that we are not finished, that a world we have watched for 4,000 years can still astonish us the moment we look at it more closely. Every answer Juno delivered arrived wrapped in new questions. The giant did not surrender its mysteries. It simply traded old ones for deeper ones, and in doing so reminded us how much remains genuinely unknown. And of all the questions Jupiter has handed us, there is one that even now, with our finest instruments circling the giant, no scientist on Earth can answer. It is a question about the giant's very origin, and it refuses to be solved. We have measured Jupiter's winds and weighed its mass. We have mapped its storms and glimpsed its diffuse heart. We have sent a spacecraft to circle it and listen to the signals it sends home. And after all of that, after 4,000 years of watching and a century of modern science, there remains a question at the very center of the giant that we cannot answer. It is deceptively simple to ask. How exactly did Jupiter come to be? The problem is one of time, and it is sharper than it first appears. To grow as massive as it is, Jupiter had to gather an immense amount of gas from the young solar system. But that gas did not last. The newborn sun blew it away within a few million years, a mere instant in cosmic terms. So Jupiter faced an impossible-seeming deadline. It had to assemble almost its entire vast bulk in that narrow window before the raw material vanished forever. How a planet grows so enormous so quickly is a puzzle that the leading theories still struggle to fully resolve. There is a second mystery folded inside the first, and Juno deepened rather than dispelled it. That diffuse, fuzzy core the spacecraft revealed does not fit the older, tidier stories of how giant planets form. Some scientists now suspect that Jupiter, early in its life, suffered a titanic collision, a head-on impact with another large forming body, an event so violent it scrambled the giant's insides and left the blurred, mixed core we detect today. But this remains a hypothesis, a reconstruction of a crime for which we have only the faintest evidence, billions of years cold. And there is a wilder question still, one that reaches beyond Jupiter's birth to its very travels. Some models suggest that Jupiter did not form where we see it now, that in the chaos of the early solar system the giant may have wandered, drifting inward toward the sun and then back out again, its immense gravity reshaping the orbits of every other planet as it moved. If this is true, then the very arrangement of our solar system, the position of the Earth, the reason we are where we are, may have been decided by the restless migration of the giant. We may live where we live because Jupiter, long ago, chose to move. These are not questions we can shrug away as trivial, and their difficulty is not a failure but an invitation. They touch the origin of our entire planetary home. And the honest truth, the truth that good science insists we admit, is that we do not yet know the answers. The giant keeps them. For all our instruments and all our cleverness, Jupiter still holds the story of its own creation just out of our reach, a mystery patient enough to outweight our curiosity. But there is one final thought, and it is the heaviest of all. Because whatever the giant's origin, its story is not separate from ours. In a very real sense, the fate of the Earth may still rest in Jupiter's distant, indifferent hands. We have traveled a long way together, from a light in the night sky to a bottomless world of storms, from diamonds falling in the dark to oceans hidden beneath ice, from a moon on fire to a spacecraft circling a giant we are only beginning to understand. And now, at the end, we arrive at the thought that ties all of it back to you, sitting here on this small blue world. Jupiter is not a distant curiosity. Jupiter may be one of the reasons you exist at all. Consider everything we have seen. Jupiter's immense gravity has, across billions of years, helped shape which objects reach the inner solar system and which are turned away, part of the long balance that gave life on Earth the uninterrupted time it needed to arise. Its ancient migration, if the models are right, may have helped set the Earth in the very orbit where liquid water, and therefore life, became possible. The giant is woven into the deep history of our planet in ways we are still only learning to trace. We are not merely Jupiter's neighbors. In a sense, we are partly its consequence. And this balance is not finished. It did not end in the ancient past. Jupiter continues, at this very moment, to influence the paths of comets and asteroids drifting through the solar system, some of which could, in principle, one day cross the Earth's path. The same giant that has helped shelter us for so long remains a vast and powerful force in our cosmic neighborhood, capable of deflecting danger away from us, or, in some tangled scenarios, of nudging it toward us. Our long-term safety is bound up with the movements of a world we cannot control and are only beginning to comprehend. There is something humbling in that, and something clarifying too. We like to imagine that we are the authors of our own fate, and in the small matters of daily life, perhaps we are. But on the grandest scale, the scale of survival itself, we remain part of a vast machinery of gravity and motion that was set turning long before we arrived and will keep turning long after us. The giant reminds us of our true size, and there is a strange peace in accepting it. To understand Jupiter is, in part, to understand our own fragile and fortunate place in a universe that did not have to permit us at all. So the next time you step outside beneath a dark sky and see that one steady light that does not flicker, look at it a moment longer than you used to. Understand that you are looking at a failed star, a bottomless storm, a guardian and a wanderer, a world that helped make your world possible. It has watched over this small planet for 4.5 billion years, and it is watching still. And you, at last, know a little of what you are truly looking at. If this journey through the giant moved you, if it made the night sky feel a little larger and a little closer, then I would ask one small thing of you before you go. Subscribe to this channel so that we can keep exploring the wonders of the cosmos together, one mystery at a time. Leave a like on this video, for it genuinely helps more curious minds discover it. And most of all, tell me in the comments below, which of Jupiter's secrets astonished you the most? The diamonds in the dark, the ocean beneath the ice, or the storm that has raged for centuries? I read your thoughts, and I'm always grateful to share this vast and quiet sky with you. Until the next journey, keep looking up,